Hi, welcome to our math. Today I'm doing a series of videos on rationals, both expressions and equations. Right now I am doing the expressions, and what I'm specifically doing in this video is adding two fractions and subtracting two fractions. Here's where things get interesting. They get interesting because to add or subtract fractions are division that haven't been divided out. And so if we want to slip past the order of operation and actually add before we divide, what we do is we get the same denominator and then we can add or subtract the numerator. We can't ever add or subtract the denominator. If you ever find yourself adding or subtracting a denominator, stop, cease and desist. Okay, so what I'm gonna do is, I would say factor first, but these guys are factored and they're completely not the same. To get the same denominator, it's kind of like having two kids and they want to have the exact same thing, otherwise they fight and become obnoxious. The first kid has this a plus 1, so the second kid has to have an a plus 1. Now we need to multiply it to the numerator and denominator because anything divided by itself is 1, and what we're really doing is we're changing this fraction by multiplying by an interesting one, the one being a plus 1. All right, now this kid has an a plus 3 and an a plus 1, so the second kid's like, hey, I need an a plus 3 as well. Now, they happen to be written in the same order. They don't have to. Multiplication is commutative. It can be written in either order. I'm gonna quickly slip away from the full fraction. This is a little bit tricky, and focus on the numerator. It's tricky because you have to remember to bring the denominator back. Always double check what you're actually answering. But I find when I'm doing a lot of manipulation, it's easier to do a polynomial versus a fraction. It's just less writing. So 6 times a plus 3 plus 9 times a plus 1. Distribute 6a plus 18. I'm going to distribute and stack 9a plus 9. Everything's positive, but if it wasn't, the stacking would help me combine like terms appropriately. 15a plus 27. And the last thing I'm going to do is I'm just going to factor. A 3 comes out of this, 5a plus 9. Now I'm going to bring my denominator, a plus 3, a plus 1. Okay, it didn't need to be factored. It isn't reducible. It's always good to make sure. If you looked at this and knew it couldn't be reduced, you might not have to actually factor, but you always want to reduce your fractions, and this is now a reduced fraction. For my second example, this one's a really nice one because it has a common denominator already. All we need to do is subtract the numerators. All we need to do is take 2h minus 3 minus h minus 6. So 2h minus 3, distribute this, minus 1h plus 6 becomes h plus 3. Now let's see what happens if you forgot to distribute and you just wrote minus h minus 6 and then you subtracted the h and subtracted the 6 because you forgot to distribute the negative because you feel you don't need to write parentheses because writing those two parentheses takes way too long. You would have ended up with minus 3 minus 6, which would have been minus 9, which would have been also a reducible fraction. And so you're sitting there going, oh, I can reduce it. I'm pretty sure I'm right because, hey, not all fractions are reducible. But let me tell you, us teachers are pretty brilliant at being able to write problems that can be done if you do it the right way or if you do it the wrong way. And writing these parentheses and distributing the negative takes such a small amount of time. It is ridiculous not to take that extra step. Now you could have up here turned this to addition and went plus minus plus, but then you're going to end up with the right answer as well because this is distributing the negative. You just have to acknowledge that minus a negative is plus a positive. You have to acknowledge the subtraction goes to every term of the numerator, not just the first. All right, I hope you've enjoyed this video. I hope you've enjoyed all my videos. Subscribe to my YouTube channel, like my Facebook page, and I will see you on the next video. Thanks!